Hello and welcome back to Calculus 1, the most important section of Calculus 1 on chain rule derivatives. About 95 and above % of all derivatives you ever take will be chain rule. This includes Calc2, Calc3, all of your differential equations and everything else, and then all of your engineering and everything else. So you gotta know this one, otherwise you are doomed, and that doom comes with like 7 or 8 O's in it. Doomed, if you don't know it. So what is a chain rule? Chain rule is a way to take the derivative of function composition. So if you remember, you have f of x equals x squared plus 3x minus square root of x, let's say. And then you have another function, g of x is, I don't know, 1 over x, whatever. Your f composed with g of x, or simply f of g of x, is going to be when you plug g into f. So it becomes 1 over x squared plus 3 times 1 over x plus the square root of 1 over x. Or g composed with f of x, which is g of f of x, which is 1 over x squared plus 3x minus square root of x. Oh, it's supposed to be a minus over here. Oops. So, function composition takes one function, plugs it into another function, and changes the function of the original function altogether. I know I talked about this on a day one, and I gave you an example of a bag, of a bag, right? Take a backpack. You take a backpack, and it has a function, and its function is to store objects inside. And then I said, depending on which objects you plug in inside, and each one of those objects has its function, depending on what you put inside, you will have the function of the entire backpack change. What can you put in a backpack? You can put books, becomes a school bag. You can put your clothes, becomes the overnight bag, you go for a night somewhere. You put tools, becomes a tool bag. You put a parachute, you can jump out of an airplane, right? So the function of your bag changes with what you put in the bag. So now we would like to know what is the way to find the derivative of the composite function. So, for instance, what is the derivative of 3 over x plus 1 squared, right? If you have something like this, what is the derivative of this? So that's the goal of the whole lecture. So where do we begin? Well, I can give you the formula for this, but if you don't have a pre-calculus skill of decomposing these functions into their original functions, you will be in trouble. So before that, let's first take a look in which way we decompose this into f and g, or more, f, g, h. Maybe you have 3 or 4 or 5 of these nested, and it's possible. So what do I have here? Well, we can definitely say, can I just go and say f of x is equal 3 over x, and then g of x is going to be x plus 1 squared? And the answer is yes. But see, this g of x plus 1 squared is still composite. It's still composite. So I'm just going to call this x squared, and then there is another function which is x plus 1. So now you decomposed everything. Look at this. You plug x plus 1 here, it becomes x plus 1 squared, and then you take that and plug it here, and it becomes the original problem. So this is what you have for these particular problems. Let's do another example. How about if I have the composition as sine 3x squared? Well, the f of x is the outer function, which is clearly sine x. And then this x gets replaced by g of x, which is 3x squared. Now you get to plug this in here, and you get the function. It's a very systematic way. How about ln squared of x plus 3? Fine, we can deal with that. What is my main function here? Well, in order for us to discover that, let's first rewrite this the way this square is not in a way. As soon as you write it this way, and you remember that this has to be the same for sine and cosine, right? If you have a square here, it just goes on everything. Immediately now we know that f of x is x squared, because there is something squared. So this is a skill that you need to have to survive this stuff. And then we dig a level in for g of x, and that's just going to be ln x. And then another level in to get x plus 3. So what we are doing now here is decomposing composition into basic functions, because we will be taking derivatives of each one of those individually. So now it is time for us to write down the formula for chain rule and then start cranking literally 7,000 problems to practice this. So the derivative of function composition is f prime with g still plugged in times the derivative of g prime. This is one of the most important formulas of your Calculus 1 venture over here. That's what it is. Let's work this out on the most basic example you can think of, the derivative of e to the 3x. You already memorized the answer to this, but now I want to use chain rule because we don't want to memorize those formulas anymore. So first off, my f of x, the main function, is e to the x, and the function that it's plugged in is 3x. Because when I plug in this 3x for this x, it becomes e to the 3x. So we're good. So what do I do now? Well, I need to take the function of the main function, so that's going to be e to the 3x, because g needs to be plugged in, right? You see, it's g still needs to be plugged in, and g is 3x. And then I need to times that with the derivative of g, Well, I know that g is 3x, so the derivative of that is 3, to give me 3e to the 3x as we memorized in our formula. What's the derivative of sine of x squared? What's the outer function f of x? Come on. Sine x. And what's the g of x that's plugged in? You have to say it louder because the air conditioning. I can't hear. X squared. Good. What's the derivative of sine? Cosine. So cosine x squared times the derivative of g of x is 2x for a total of 2x cosine x squared. What is the derivative of 4 over square root of cosine x? Doesn't matter what we put. What should we do first in a question like this? 4 over x. Oh, you want to decompose it. Okay. So f of x is 4 over x. I agree. What's my g? Square root of x. Nice. And now there is a third one. Cosine x. You need to be able to take this now, plug it here, you see it's a root of cosine, and then you take all of that stuff and plug it in there, and you get the answer. I mean, you get the original function. So to do this, I'm going to rewrite it as 4 cosine x to the negative 1/2. Because it tends to be easier if you write it in this way. So this one goes into these. But if you rewrite it, then you have less stuff to worry about, because your f of x is now 2x to the negative 1/2, and your g of x is cosine x, so you have one function less. Right? So what happened? How did this happen? Just rewriting and using algebra, we killed one function. Please note that this negative 1/2 contains two functions in it. It contains this negative 1 on x, and it contains 1/2 of the root. Negative 1 and 1/2, negative 1/2 combined in 1, which is the reason why we lost one of the levels. Just by rewriting it, we lost one of the levels because we combined two of the levels into a single negative exponent. It's a really cool thing. So now taking this derivative is easier. It wasn't hard before, but now it's even easier. So we take, why did I put 2x? It's a 4x. It's a 4. Probably I was thinking of a half. Anyway, so take the derivative of this, which is 4 times negative 1/2 times cosine x times negative 3/2, and now times the derivative of the cosine is negative sine x. Negative and negative goes positive. It becomes 2 sine x divided by cosine cubed x under the square root. Actually, can we do better? No, we can do better. We can do better. Because now this breaks down into sine x, cosine x, square root of cosine x. If you take 2 cosines away, under the square root becomes square root of a cosine squared, and that's just a cosine outside. So 2 over tangent x over square root of cosine x. That's a better form. Not that there will be anything wrong with the other one. It's just we try to find the smallest possible way to. Alright, so what else do we have? Let's go to homework and pick examples from homework. I mean, I can come up with technically anything you write down is going to be chain rule, unless you are just putting in basic functions. Those are basic. Derivatives, chain rule, homework. There we go. Let's see what they have in mind. The derivative of secant 3x plus 1. What's the derivative of secant? What's the derivative of secant? So our outer function f of x is secant x, and our inner function is 3x plus 1. Now, here in blood, the derivative of secant x is secant x tangent x. So, we have secant 3x plus 1 times tangent 3x plus 1, and now times the derivative of this is 3. So the total is 3 secant 3x plus 1 tangent 3x plus 1. This is cool. The derivative in respect to t of e to the tangent t. Think about this one. So what's f of x? I mean f of t. Come on, guys. F of t is e to the t. Thank you. Whew. And then g of t is tan t. So the derivative is, well, it stays the same, and then times the derivative of tangent, which is very good. Done. What is the derivative of 2x to the 6 minus 3x cubed plus 3 raised to the 25? What's f of x? What's g of x? And then do it. What's f? Anyone? What's f? X to the 25th. So our g is 2x to the 6 minus 3x cubed plus 3. So, to find the derivative, please, all of this becomes just one thing. It's like x to the 25th. So the derivative of that is 25 x to the 24. Do we all agree? And you just have to fill in 2x6 minus 3x cubed plus 3 for now. And then times the chain, which is the derivative of the inside, which is 12x minus 9x, no, 12x to the 5, 9x squared, and that has to be in parentheses. There you go. Done deal. We have a lot more stuff to do in this section. So I will open the homework for you to practice, but the next time there will be part 2 for chain rule. And we'll deal with the combinations of chain rule with product and quotient and all of the other things. So you won't be able to do all of the homework unless you sit and watch some other lectures that are from before and things to... You can't solve all the problems yet. Only up to problem 40 in the textbook. After 40, we haven't talked about it yet. See you next week.